For the first scenario, it's very easy. The study period equals to the useful life, and all the useful lives of different options are the same. Okay, so to do that, as what I said, you just use equivalent worth methods. You can calculate PW or AW or FW, right? And then you just compare which one is bigger. And if it is investment alternatives, you just find the bigger one, the more positive one as the good option. If it's a cost alternatives, which means your cash flows are all negative numbers, then you will find the least negative present worth or future worth or annual worth. That will be your better solution. Okay, and but you don't need to calculate all the PW, AW, and FW at the same time. You just choose one, and any one of them will give you the same answer. For me, I usually use the present worth. Okay, that's just a personal preference. You can also use annual worth or future worth to compare. So here is the example of useful lives equals to the study period. So here we have best flight in incorporation. It is considering 3 mutually exclusive alternatives for implementing an automated passenger check-in counter at its hub airport. Okay, so check-in counter, they might have different efficiency. Some counter may be working faster than the others, right? And they also may cost different price. So each alternative meets the same service requirements. They reach the same goal. But the differences in capital investment amounts, like how much you pay for each of them, and benefits, like how much you can save. So the study period is 10 years. And the useful lives of all 3 alternatives are also 10 years. So this is an easy case. Market values of all alternatives are assumed to be 0 at the end of their useful lives. So after they're done their work, you don't sell them to any secondhand market. If the airline's MARR is 10% per year, which alternative should be selected in view of the cash flow diagrams shown on the next slides? Okay, so the diagrams are given in this problem, and so let's see what's the difference between these 3 options. So the first alternative A, at the beginning you pay this much to buy the equipment, to buy that check-in counter, and then every year you can save 69,000 for 10 years. And option B, you need to pay more at the beginning to buy the system. And of course, every year you can save more. That's your saving is a receiving, okay? And option C, it's a price in the middle of the option A and option B. And also the savings or the profit you gain is also in the middle of the first and second option. So which one is the best alternative? Well, I just want to convert every cash flow to the present worth so that I can compare which present worth is bigger. And because these cash flows, we have negative ones and positive ones, so it's investment alternatives. So which means in the end, all the present worth will be positive, and you just choose the biggest one. Okay. So for example, for alternative A, the present worth has 2 parts. PW1, PW2. PW1 is from the present initial price, which is negative, you're going to pay, and actually you're converting the present worth to present worth, which means you don't need to convert at all. and the present, and PW2 is from the annuities. It's positive, right? So you want to convert annuity to present worth. So this is our PW1, and this is how do we convert the annuities to present worth. So PW2, and after the calculation, this is your total PW for alternative A. So you want to do the same thing for alternative B and alternative C. And then this is the PW for alternative B. This is the PW for alternative C. So you want to compare which one has the biggest positive number. Obviously, it's alternative C. So C is the best.